In the previous video, we looked at the proof for the centripetal acceleration, v squared over r. So when we're dealing with forces equal to ma in these questions, the force directed towards the center will be mv squared over r. We also have a mass of m in this question and a radius of 50. So I'll just sketch this diagram. Create the arc and the radius of 50. And the coefficient of friction if the car just begins to slip. So it's just beginning to slip, we're saying F is equal to mu r. And the forces in this are mg and the reaction at the road. And the force towards the center of my centripetal force, and that has to be equal to the force ma as well. So let's just say that r is equal to mg to begin. So mu r is equal to mu mg. Then we have my centripetal force from force is equal to ma. So this m times v squared over r will have to be equal to this mu r, which is mu mg. So simplifying this down with the information we're given the radius is 50 and we're given the speed of 21. So 21 squared over 50 is equal to mu g. So just to get mu on its own, I'll bring the g underneath to 9.8. So 21 squared over 9.8 times 50, just taking out the calculator, mu is equal to 9 over 10 or 0.9 for this question, question 1. Question 2, part 1, we have radius, same thing as a car going around the bend. Radius, we have the coefficient of friction, we have mu as 2/3. Find the speed, so we're looking for v in this case. So a quick sketch of my arc. My car is this dot. We have a radius of 24. We have mg, force going down, and r as my force going up. So r is equal to mg. Mu r is equal to mu mg. And we have mu as 2/3, so this is 2 mg over 3 for mu r. We also have force is equal to ma, which is equal to mv squared over r, which is equal to m. We're looking for speed, so v squared over r, which is 24. So dividing by m, dividing by m, letting it equal 2 mg over 3. First, I'm skipping a stage, 2 mg over 3, and then dividing by m, we're going to get v squared is equal to just straight across 2 by 24. I don't need to divide by 3, so I'll just say 48g over 3, which could be simplified, but I'm just going to type this into a calculator. The square root of 48g over 3 is giving me 12.52 meters per second for part 1. In part 2, in wet weather, the max speed is 7. Find the coefficient of friction between the tires and the wet road. So we're given speed is 7. V is equal to 7 for part 2. We want to find the coefficient of friction. So coming from here, we have mu mg is equal to mv squared over r. It's not going to change, we just need a different mu here. So we have, well, we are looking for mu, so leave mu on its own. Mu is equal to v squared, which is 7 squared, over r times g, which is g times 24. So mu is equal to 49 over 24 times 9.8, which actually works out evenly to be 5 over 28 for the coefficient of friction in question 2.